Okay, so we have completed the structure of benzene, and today we are going to start with the reactions of benzene. So, benzene is more stable than alkenes towards electrophilic. Sorry. Polymer. See the timing addition reaction due to high stability of its delocalized by electrons. And due to this reason, we need, if we have to do the electrophilic addition in benzene, we need extreme conditions. Under those extreme conditions, electrophilic addition can be done in benzene, but under normal conditions, and benzene doesn't go electrophilic addition reaction. So the usual reactions which benzene can normally undergo are benzene undergo electrophilic substitution reactions readily. The pairing of benzene stay intact. The pairing is the inner circle which we made in the structure. So because the electrons are continuously delocalizing and moving, and that's make it more stable. So it stay intact in most of the reactions. You are not noting down? So we are going to start with electrophilic substitution in benzene. So we know that is a hexagonal ring. And there is a circle inside which shows the pi system, and its formula is C6H6, right? So this basically, this circle inside is representing delocalized pi electrons, which are in total 6 electrons are here. Now, what they cause? See, there are 6 electrons in the center which are continuously moving. Due to this, just give me a minute, please. So due to these 6 electrons, uh, there will be high electron charge density around benzene ring. High electron charge density around benzene ring. If there is a high electron charge density, then due to this, it can attract electrophiles. Electrophile are electron deficient species which usually have a partial positive or positive charge. So it can attract electrophile towards itself. So now, under electrophilic substitution reactions, the first reaction is with halogens and specifically with chlorine or bromine. So chlorine or bromine reacts with benzene in the presence of a catalyst. That catalyst is also called halogen carrier, and that halogen carrier or catalyst that we use is anhydrous aluminium chloride or anhydrous aluminium bromide. Either one can be, any one out of these two can be used. So if we react the chlorine with the benzene, then we call that chlorination. In chlorination, benzene reacts with chlorine in the presence of that catalyst, which is anhydrous aluminium chloride or anhydrous aluminium bromide. So what will happen? We know that in benzene ring, there are 6 carbon atoms and each carbon atom is bonded to a hydrogen, right? So one of the hydrogen is displaced by one of the chlorine atom, and the hydrogen that is displaced bonds with the other chlorine to form HCl. So here the product is named as chlorobenzene. Then when we react bromine, then it is called bromination. In bromination, in the same manner, benzene molecule reacts with the bromine forming bromobenzene with, now the product will be HBr. So these are the equations. Are these equations clear to both of you? Then, okay, now we are going to discuss formation of electrophile. So we have a catalyst. The catalyst is anhydrous aluminium chloride. What is the special about this aluminium chloride? Or what is special about aluminium bromide? Yes, Kubra, can you recall? Yes, Hassan, can you recall? Very good. These are electron deficient. So, anhydrous aluminium chloride or anhydrous aluminium bromide generates electrophile. They basically generates electrophile by reacting with chlorine or bromine. So basically what happened that chlorine or bromine molecule polarizes just give me a minute please. Okay. So chlorine or bromine molecule polarizes and forms dative bond with catalyst and releasing the electrophile. So let's see what will happen. This is a chlorine molecule. and here I have aluminium chloride. So we know chlorine have a 3 lone pairs of electron with it, right? So, right? Each chlorine atom have a 3 lone pairs of electrons with it because in its valence shell there are 7 electrons and 1 involved in bonding, so 3 left. So what it will do? It will attack from this lone pair to this aluminium to form a bond with aluminium, as we have seen that this is electron deficient, it have a space for 2 electrons, right? So in the meanwhile, chlorine breaks this bond and takes this pair of electron along, and as a result, a chlorine that is left behind have a 1 electron less, so it becomes a positive ion, right? And the one which approaches the AlCl3 is becomes a Cl negative, becomes a chloride ion. So when that chloride ions joins with AlCl3, it will turn into AlCl4 negative. So here this positive ion is an electrophile because it is an electron deficient species. So this becomes electrophile. So see, this is how an electrophile is generated. Now I have shown you how chlorine becomes electrophile by reacting with AlCl3. In the same way, if you will see, you will find that bromine also becomes electrophile in the same manner by the reaction of aluminium bromide with reacting with aluminium bromide forming bromine positive ion and AlBr4 negative. The same thing happen over here as well. Okay, now interestingly, what else can be happen? See over here. For example, there is a chlorine molecule, but we use the catalyst AlBr3. Then again, same thing will happen. We left with the Cl positive, and here we are going to get AlBr. Yeah, very good. A AlBr3 Cl negative. And in the same way, the fourth possibility, when there is AlCl3 as a catalyst and we are using the bromine molecule, so we get bromine 3 positive and then AlBr Cl3 negative. Is everybody done with the above text? Okay, now complete this. So after this, we are going to discuss the mechanism. We just discussed how the electrophile can be formed. Get it? Okay. Now we are going for mechanism. For 1 mark, examiner asks you to write the equation for the formation of electrolyte. So first we see the mechanism of fluorination. So here we have benzene ring and we have electrophile. So what benzene ring will do, as it have a high electron charge density, so electrophile would obviously attract it towards itself and come closer. When it reaches closer to it, it will attack from its pi electron system to this positively charged electrophile. And when this happens, we know that each carbon have one hydrogen, right? So, for example, this chlorine is bonded to this carbon. So I'm going to show a hydrogen over here. Okay, so if this attack is taking place, so all as we see chlorine is positively charged, so both the electrons are provided by the pi system. Pi system have initially 6 electrons. Now out of these 6, 4 electrons, 2 electrons are transferred towards chlorine. So now the pi system is not uh, intact anymore, and that's why we are going to show the partial circle and a positive charge over here. But now what will happen? The carbon breaks the bond with the hydrogen, takes the pair of electron and introduces back in the pi system to make the pi system, to restore the pi system again. So when this happens, a hydrogen ion is being released, but that hydrogen ion is actually, uh, you know, it was the catalyst which turns into this. So we know catalyst uh, remains unchanged at the end of the reaction. So that hydrogen ion release interacts with the catalyst, and then see what will happen. We will get the benzene, a chlorine bonded to it. The hydrogen that comes out takes the chlorine from the AlCl4 negative, forming HCl. That was our second product in the equation. If you see over here, see, we are getting HCl, and AlCl3 is restored, the catalyst. Same thing happens in bromination as well. See, the whole mechanism is going to be same. Only the difference is the element. Now we have to mention uh, bromine, right? Bromine instead of chlorine. So Br positive, Br, HBr, Br, and AlBr3 is restored. And here we have AlBr4 negative. Yes, is this understandable to both of you? Okay. Done? Okay. Now, the next reaction is Friedel-Crafts alkylation. Um, okay. In this reaction, alkyl side chain substitute hydrogen to form alkyl benzene. So, if alkyl side chain is substituting the hydrogen from the benzene, so what will be our electrophile? Alkyl, obviously, because electrophile always substitutes the hydrogen. So, alkyl group act as an electrophile and alkyl halide is used as a reagent, reacts with benzene at higher temperature in the presence of, again we use the same catalysts, anhydrous aluminium chloride or anhydrous aluminium bromide. So we have a benzene ring. It reacts with a alkyl halide. For example, we take the alkyl halide, a chloroethane, which have a two carbon chain, and on one carbon a chlorine is bonded. The catalysts are same. So what we get now, this chlorine, which is bonded to alkyl chain, bonds with the hydrogen that is substituted from the benzene to form HCl, and the CH2, which is bonded to chlorine, that CH2 bonds with the benzene ring. And as a result, the whole alkyl chain is gets bonded to benzene ring, and we get ethyl benzene over here. So, in the similar manner, for example, if you see, okay, let me do it this way. We have this structure now. And here chlorine is bonded. So that chlorine goes same. And this carbon, actually, let me highlight it. This carbon is going to bonds with the carbon of benzene, and the whole structure gets flipped. So see that similar carbon is over here now. because chlorine is removed from this carbon, so this carbon is going to bonds with the carbon of the benzene. Is this clear? Okay, just complete this. That's all for today. In the next class, we will discuss the formation of electrophile. It is exactly going to be the same as previous one. And then mechanisms. Okay. Take care. Allah Hafiz.